Hi there, I'm on site at Electronica 2024, and joining me today is Mark Noland, Technology Manager, and Jerzy Mrugala, Embedded Memory Sales and Application Engineer at Kingston Technology. We're going to be talking about their embedded and industrial SSD solutions, as well as look at the key features, performance benefits, and how they're well placed to address the evolving demands of industrial and embedded applications. Thank you both for being here.
Thank you for having us.
Could you start by giving a quick introduction? Maybe Jerzy, we'll start with you.
Yes, my name is Jerzy Mrugala, and I work for Kingston Technology in the embedded division for the last 17 years. It's been a long road, and I'm here to support all the customers who have an application for embedded flash or DRAM.
Thank you.
I'm Mark Noland, Technology Manager for Industrial SSDs. I've also been at the company about 7 years with Jerzy, and I basically assist our customers in determining, the right match for their products when they need to put embedded SSD products into their designs.
Great, thank you both for that. And could you quickly talk about the company itself, who is Kingston Technology?
You want to take it?
Go ahead.
Kingston Technology is, we've been around for the last 40 years, and what we deliver is quality memory solutions for all kinds of applications, whether it be a consumer electronics, gaming, industrial, and embedded as well. So 40 years of experience delivering all kind of flash and DRAM solutions, and I think it's been great 40 years to be able to serve our customers year by year.
Great. So let's start by talking about the demands of industrial and embedded applications today. What are some of the key trends you've both noticed?
Well, on the SSD side, embedded technologies usually want smaller capacities because usually the SSD storage is there to house an OS, which is typically a pared down Linux kernel, and it's relatively small, but it's, so we have capacities going from 256 gigs to 1 terabyte typically for our industrial SSDs, whereas like the consumer products, might be 480 gigs to 4 terabytes, 8 terabytes, 16 terabytes. One of the trends on the SSD side is that the demand for capacities are growing with some AI applications. So we're seeing that move, that it's a lot more conservative in industrial products because people want, products that will have a long shelf life and that. And so we're seeing the slow move to larger capacities, which I think there's demand for it, but like the sales are still pretty in the sweet spot of 256 gig to 1 terabyte.
Great, thank you for that. And Jerzy, what have you noticed?
I would say in industrial and embedded, there is a few key features that customers are looking for. And the first one is reliability. The memory solution is supposed to work for 10 years, 15 years. So customers are looking for something that is reliable, that is durable, that's been tested for industrial applications. So we work closely with chipset vendors like NXP, Texas Instrument, ST Micro, and customers want something that doesn't change inside. So longevity and stability of a part number. And I try to put myself on the customer side every day. I go to see customers and I think, what are you guys looking for? And the answer is simple. We want something that will work for ages and will not change. Obviously, the changes are inevitable, but we work with a JEDEC standard primarily. So we try to give customers one part number for as many years as possible. And as like Mark said, we also notice a trend in server enterprise AI industry. And and higher capacities. We started with 4 gigabyte. Now 128 gigabyte is very common capacity. So yeah, many years, reliable parts, no changes, and let us know if something changes. Give us a PCN, give us a warning, give us a notice. That's what customers want from us, and we're here to deliver.
Mark, you just spoke about the increasing demands on capacity, which I think leads me nicely into my next question about primary pain points or challenges. Could you talk about that from the SSD side?
Yeah, so in the space for IoT devices and edge compute that's really growing exponentially right now, there's a balance between the desire to have the latest, greatest technology, but also to have something that is stable and mature. And so, when you're designing an appliance or an edge device, you want it to be something that'll have a long future to it, minimally, like the product's gonna last 5 years or something, and it might be put in a train car and not touched for, half a decade, right? So you want something that's gonna last and be durable, but you also want something that's cost effective and maybe not cutting edge technology, so something that's mature so that it's dependable and reliable. And so, for example, we have a line of PCIe devices that we're selling into that space, and we have to do a refresh. You have to do a refresh occasionally, but that product has been out for over 3.5 years, and we'll do a refresh in the middle of next year on the PCIe side, so there's the sort of balance between, like the new and the mature. So having a product that's been around for 4 years, so our next gen one will probably, we forecast out for like 26 months, but the last one was about over 3.5 years. So when the new one comes out, we'll get customer samples early and then start sending those out. And that new product will, most likely be around at least 2.5, 3.5 years.
I think it's a fine balance to strike.
Yeah, you don't want something that's like too old, but you don't want something that's too new that it's not, you don't know where it's, if there's any issues that might come up. And to that matter, SATA drives are still very popular in the 2.5-inch form factor and M.2. It's an older technology, but it's very mature and very reliable, and you know what it's going to do. And you're going to have, reliable performance, cool temperatures, and so still very popular in the industrial space.
Thank you for that. On the embedded side, is there anything you want to add, Jerzy?
Yes, I think we're a bit different to Mark's business. In whatever is soldered down to the motherboard, we noticed that customers are more looking at the total cost of a solution. So they would not be interested in price per gigabyte. So let's say we offer them 256 gigabyte instead of 128 because it's cheaper per gigabyte. It doesn't work like that. When a customer comes to me and say, we want to manufacture a board under $100, and the volume is 100K per year, it becomes clear to me that they're not looking for something that will cost $10. They would like to have something that is enough capacity for the workload they have during the number of years they want to support the product, but they also want it cheap, so they can close this BOM in under $100, and that becomes a challenge because, as you know, the semiconductors are moving to higher capacities, and it's harder to get lower capacities actually that will have this sub $2 price per unit, and that's when I think we have to work with partners like DigiKey, with all the partners that help us to make them aware that there will be changes. They may have to pay $250 and get 8 gigabyte next year or in 5 years. But they should be rest assured that we will take care of them. We'll deliver a product that is a replacement for the current 4 gigabyte, let's say, at a good price, and their business will be safe. So that's what I have to add.
Thank you for that. Earlier, we spoke about the demands of industrial and embedded applications today. In your opinion, have they evolved over time, these demands? And if this is the case, how have you at Kingston Technology kept pace?
Well, on the SSD side, in the previous years, up until maybe the last year or so, I think AI is really starting to impact everything across the board, where everything's going to be at least an IoT device of some kind now, regardless of what kind of appliance it is. And more they're connecting it to an AI structure somehow, whether it's local or remote, collecting data, feeding data, processing data. And one of the things I noted is that recently the demand for higher capacities is going up a lot more. That it's not necessarily the sales are starting to increase slightly, but the demand for new products, there's more and more inquiries. And one of the awesome things working with DigiKey is our products are made to order. So if you want samples, we have samples, but DigiKey is stocking samples. So it's really cool because if you need a bunch of samples fast, you can go to DigiKey and you don't have to wait for a couple of weeks to have them made up. So it's really great working with you guys. And we do have like some larger capacity devices coming in our next gen products.
Yeah, I'll have to agree with Mark. DigiKey is a great value and added to our business. And sometimes we don't even know. Customers come to us, they want to place an order straight away. For me, I need to verify, have you guys qualified the device? Where did you get samples? Oh, we have them from DigiKey. That's a great asset. And in terms of trends and in demand, definitely AI, definitely connected device, definitely smart home hubs and automotive applications. We currently don't hold a ACQ certification, but we started rolling out 105 degrees embedded flash to support some of the aftermarket upgrade applications.
Which I think is a really good segue into the next question about the embedded solutions you offer. Could you take us through the core solutions and their key features?
Yes, definitely. So primary solution is an eMMC, which is, you can look at it as an embedded micro SD, but it's much more than that. It's a product that which BOM is controlled, so it doesn't change for years. And again, the little 11.5 by 13 millimeter device can hold 256 gigabytes of capacity. It's crazy. You look at it and how is it possible? But it's got non-flash inside controller. So if a customer used to work with SPI, NAND, NOR, and they look at this, it's a great solution because all this, it's a managed NAND, so all the kind of operations like wear leveling, like bad block management, like data retention is all controlled by the intelligent processor inside. And then on the other side, we also have, because we make memory, we would cover flash and DRAM, and every design should have some kind of a storage to boot from and some kind of a DRAM solution to operate. And obviously we offer DRAM, DDR3, DDR4 chips, low power D4, low power D4X, both in standard and industrial temperatures, which is very important for guys like embedded boards, single board computers, computer modules. And we try to be very close to chipset vendors because that's how you actually evaluate the product. From customer side, they want to bring it very fast to the market, as fast as possible. and they would be looking for help from chipset vendors. Do you guys have board support package? And of course, if Kingston works with NXP, they would have Kingston on BOM to support us. And they would not be willing to go somewhere else. If there is a solution with Kingston there, which works, they would most likely choose Kingston as a partner. And then, of course, we have some other embedded devices like EPOP, EMCP, which is a combination of DRAM and store and NAND in one chip, which is only for boards that have space constraints. It's a bit more expensive, but if you have a really tiny board, you really have no other choice. So that's the portfolio we offer, and we try to cover both standard and industrial temperatures for our customers. And we go as high as 105 degrees Celsius for eMMC.
So let's pick up this point you just mentioned about industrial temperatures, which is obviously one of the more challenging environments for embedded applications. How are you ensuring data integrity and reliability of solutions when they're deployed in these kinds of environments?
It's a very good question. Thank you. It's down to testing again with chipset vendors. We work with them, and we select a number of boards that are typical for industrial applications. So I'm talking here IMX 6, 7, 8, 93, 95, Texas Instrument, and ST Micro, and try to run the tests like power failure tests, data integrity tests, but also the most challenging test is to program at high temperature and read at minus 40. Once the carefully selected NAND passes this test, we all good. We in business. But that's the most challenging test, and that's how we do it. We just if a firmware doesn't pass qualification, we find bugs. It never gets released, and it sometimes happens. We late with release, but we release something that is reliable and goes on forever.
Which is the most important thing.
Exactly.
So Mark, let's go to you. Could you talk us through your SSD offerings and their key features?
Well, so we've had a line of PCIe devices that have, Gen 4 by 4, M.2, and like 2230 and 2280 form factors, but and those are going. We're going to be having a generational change next year. But one of the things with our industrial drives is we have a dedicated team that supports it. So there's folks to help you if you're needing to do engineering. We have field applications engineers that we can go locally to any customers in a system. We have a lab if somebody wants. We can actually bring their device into our lab and run JEDEC standard tests on it and help them validate a system. In the last year, we brought out an iTemp device, and those we had to pick between. We're relatively conservative, so do we do an SATA one or an NVMe one? And we decided, because the SATA market for iTemp is still about 60% SATA, 40% PCIe. So we went with SATA first as a foray into the iTemp space, and it's been very successful. We're evaluating on the iTemp side for PCIe, since the controllers need to be vetted thoroughly. So we're looking into that and trying to find the best product. But the iTemp SATA devices have been doing really, really well. And I think, having worked at one of the semis before, the big difference I see with Kingston is our ability to support customers and the resellers directly in helping make the sales and getting the appropriate device for the appliance that it's going into.
I think it relates nicely to your point earlier about this balance you strike when it comes to new and emerging technologies and older technologies, because both have their pros and cons, right?
Yeah.
So you mentioned it very briefly, this the form factors you offer. You offer a variety on SSD solutions. Could you tell us a little bit about how these form factors impact installation flexibility for embedded system designers?
Yeah, so one of the, if it's a handheld device, lots of times you have a constraint of space, right? So, smaller devices lend themselves really to soldered down memory and storage solutions. But if you need something bigger and you need say you need the performance of an NVMe device in there, the 2230 form factor is very popular on NVMe. And on the SATA side, there's a 2242. So that's for small laptops, tablets, ruggedized devices that might be in vehicles, point of sale devices that need larger volumes of storage for logging, things like that. And so on the SATA side we have everything 2.5 inch, 2280, 2242, and then on NVMe it's basically 2280 M.2 and 2230, so 30 millimeters for the little postage stamp one, which is becoming more and more popular.
Well, thank you both. You've done a good job of taking us through the solutions and their key features. Let's talk a little bit about lifecycle management and long-term product support. What can your customers expect?
So yeah, it's a great question. It's a great topic, and I think I mentioned it earlier. One of the challenges is to provide customers with the information. So first question I usually get, one of the first questions is, how long you guys gonna have this on offer? How long is, what's the longevity, what's the life cycle? And there is, it's not an easy question to answer because the times are uneasy, and we have to rely on the non-suppliers. But I think on average, every part number should count on 3 to 5 years of longevity. And because it's managed by a standard, a JEDEC standard, there will be a replacement most likely, and there will be a PCN issued in advance. We, in my department, we use 5 months ahead. Customers will get a notification, they will have a time to qualify the replacement, and obviously evaluate, does it work, does it work, not maybe work, is there a problem? We have to be working closely with the customer to provide a reasonable, cost-effective and reliable solution. So it's very challenging at times, but I think the best way to tackle this is honesty. Don't overpromise, be realistic. Your roadmap, we never, one thing we don't do at Kingston, we don't provide 7 years roadmap because it's too long. Things may change 7 times. So we tell them how it is. We tell them we will take care of them. You will get maybe a wafer reservation. You will have, we give them our partners like distribution, and there is ways to provide longevity to customers other than just 3 years. We can go way beyond that by working with the demand planners, working with the purchasing divisions. We get this information. We kind of pain for some customers because we want to know, so what's your forecast? What do you think you're gonna do next year? How many thousands, tens of thousands? What's your prediction? And then we work with our planners internally. We make sure that there is enough non-supply to cover all customers, plus maybe another 20% just in case.
Great. Well, thank you for that. To wrap this up, tell us a little bit more about your partnership with DigiKey and what it means for your customers.
Well, like I said before, working with DigiKey for Kingston is pretty terrific, just because you're excellent partners at helping us seed equipment into the field for engineering samples and bringing new customers to us. And we feel confident in if we get leads and bring them into DigiKey, that they're going to be taken care of. And we kind of have a really great system working hand in hand with DigiKey.
Well, thank you both for joining me here at Electronica. It was great to talk to you.
Thank you for having us.